Hadley sail that is closest to the equator consists of winds converging and rising at the equator and then diverging north and south of the equator as it reaches the upper troposphere. The winds then sink at 30 degrees latitude as they converge with winds in the Ferrel sail. They hit the surface and diverge back to the equator to complete the sail. This provides the equator-ward wind component of the trade winds. Ferrel sail has winds sinking at 30 degrees latitude and then traveling poleward as they hit the ground and diverge with winds from the Hadley sail. This provides the poleward component of the mid-latitude westerlies. These winds travel towards the poles until they converge with winds in the polar sail at 60 degrees latitude. These winds then rise up and spread out equator-ward to complete the sail. Polar sail has winds rising up at 60 degrees latitude and spreading out poleward as they reach the upper troposphere. The winds sink down at the poles and then diverge towards the equator until they reach 60 degrees latitude, where they rise up again to complete the sail. They provide the equator-ward component of the polar easterlies. If there was no Coriolis force, the global wind belts at the surface would blow strictly in the north-south direction. Due to the rotation of the Earth, any movement of air in the northern hemisphere is deflected to its right, and in the southern hemisphere is deflected to the left. This apparent deflection is called the Coriolis force. The amount of deflection the air makes depends on the speed at which the air is moving and its latitude. Therefore, slowly blowing winds will be deflected only a small amount, while stronger winds will be deflected more. Likewise, winds blowing closer to the poles will be deflected more than winds at the same speed closer to the equator. The Coriolis force is zero at the equator.